Hi, my name is Mumtaz and I'm thrilled to be presenting a systematic mapping study on architecture smells detection that was published in the Journal of System and Software. The study was accomplished in collaboration with Blincoe and Paramvir Singh, and all of the authors are associated with the University of Auckland, New Zealand. So architecture smells are introduced because of the suboptimal design decisions during architecture development. And in order to have good quality software architecture, the smells need to be removed. Therefore, detection methods and tools become essential for smell detection. There are a variety of techniques available for detecting several architecture smells, and the diversity in the techniques and tools motivated us to perform the mapping study so that we can report the interesting aspects for research and practice. There was also no mapping study or literature review on architecture smells detection that also motivated us to perform the mapping study. So in our mapping study, we have a total of 4 research questions. Our research question 1 aims at the demographics of the published work with goals of identifying when the articles are published, like reporting the year of publication. Secondly, venue of the published articles, for example, journal, conference, or workshop. And at the end, origin of the articles to showcase whether the article is originating from academia or industry. Our research question 2 covers the detection techniques for architecture smells. The goals were to identify the smells that are currently detected so that we can filter out those smells that do not have detection methods yet. Second, architecture styles handled by the techniques so that we can report the styles that are not investigated yet. And finally, the evaluation of the techniques to see how the techniques are validated. Our research question 3 deals with the detection tool. Our goal was to identify the smells detected by tools, how the tools are validated, availability of the tools, for example, open source or commercial, and finally, what languages are being supported by the tools to see whether how tools can work with projects developed in different programming languages. Finally, in our research question 4, we list the limitation of the techniques and tools, which include listing those architecture smells that are currently not detected, architecture styles that are understudied, quality characteristics that are barely explored, and limitations related to the evaluation of techniques and tools. In this presentation, I will be talking about a few limitations in the existing methods. However, before I talk about these findings, I will first briefly explain the systematic mapping process that we used. So we follow the systematic mapping guidelines provided by Peterson and others. We start by applying the search string on various databases. After retrieving the articles, we remove the duplication to obtain the unique articles. After that, we apply the inclusion and exclusion criteria. At the end, we apply the snowballing strategy. Finally, we had 85 primary papers for analysis. As you can see in this slide, we reported various findings from our mapping study, but due to time limitations, I'm only presenting a few key findings in this presentation. So the first main takeaway is that we found many architecture smells still do not have detection methods. For example, microservice and MVC smells. Now these days we are seeing the softwares being developed using service-oriented paradigm. This suggests the practical applicability of the service-oriented architecture, which means that the methods should be developed to detect the smells in the service-oriented systems. Also, the tool support is limited to a subset of architecture smells, which urge the need to extend the tools to include the support for other architecture smells as well. Currently, the existing tools can only support detection of common dependency smells, for example, cyclic dependency, unstable dependency, or hub-like dependency, and some service-oriented smells, but not microservice smells. This is an important finding from tools perspective because in order for the industry to adopt the tools, the support for more smells is necessary. The second main takeaway is that we noticed a lack of broader focus on architecture quality characteristics. For instance, we found that maintainability and performance are often studied. However, other important characteristics like security, reliability are barely investigated. It is understandable that maintainability is widely studied because of various implications on the development cost, but other attributes are equally important, for example, security aspects of the software architecture. Similarly, there are many architecture styles that are not included in the detection method or tools. For example, cloud and Android are barely studied for architecture smells detection. Once again, cloud architecture has been popular in the recent years because many modern technologies are moving towards cloud services. So investigating such important and relevant architecture styles in detection method is also necessary. In terms of empirical validations, the detection techniques mainly included Java, C#, C++, etc. However, projects developed in other programming languages like PHP and Python are not included in the validations. We know that Python is a very popular language among development community, so it is important to include Python and other such languages for generalization of the results. And also adding more languages in the tools can help the tools being adopted widely by the community. That's all. Thank you for your attention. We encourage you to read our full paper where we discussed various implications of these takeaways and many more findings. You can find our full paper on Journal of System and Software. Thanks again, and I'm happy to take your questions.
Hello everyone, welcome back. So we have the author, the first author of this paper, that is Haris. So yeah, my first question for you is from Alex, that is here as well. So given your research, given your systematic mapping study, what do you think is the next step for the community?
Yeah, thank you for the question. In the mapping study, we found that the many smells that have methods, detection methods, but really there are tools. So the step would be that integrating those smells that have methods to tools, so that it has more audience to the community, it has more adoption and more usefulness from the industry perspective. Because usually when we do the research, we want to do the data analysis, we look for tools. So tools are important, and there are scarcity of the tools. So this is the next step, I think, that we can for the community.
And then another limitation of the current research is that all research is basically in Java. So to what extent do you think that this can impact the research in architectural smell detection?
Yeah, so the more analysis done for the Java language projects, and this is one of the shortcomings for the methods as well, because for the generalization of the results, I think more languages like Python is a very popular language these days, and other languages that are coming market these days. So I think including more languages in the analysis for the methods is so important and paramount.
And do you think that the granularity of these languages could have an impact as well? So, we lost Alice for some reason. Yeah. So in this last 30 seconds, I just remember you that we are going to have a social event. I see that only one person is in the other room. That now is okay, but let's meet all together in a few seconds in the ICPC social room. Yeah, in this last 30 seconds, I don't know what I should do, but I don't know how to entertain you. But just relax and yeah, let's meet in the other room.